Giving love to the world. We'll be raising our hands, shining up to the sky. Good morning, good afternoon, good evening, whatever the case may be. We are back, and we are better than ever for binary operations part 2. We are going to move to our last concept. So let's get to it. Shall we, Ellie? Do you mind? Love the song, but we're going to get to it. One more concept, the associative law. Okay. Remember the associative property where 3 times 2 times 5 equals 3 times 10 equals 30, and 3 times 2 times 5 equals 6 times 5 equals 30. We can move the parentheses back and forth and still get the same result. Okay. And we say that multiplication is associative on the real number system. Okay. So more generally, a binary operation star on a set S is said to be associative if we move the parentheses around and they are equal. And that's for all A, B, and C element of the set S. Now, the result doesn't have to be in the set. That's closure. We're just talking about, is the binary operation associative? Okay. And this is where you got to be a little bit careful. Okay. Determine whether the binary operations on the real number system defined below are associative. Okay. So this is A star B. And it might have been a little bit easier if we used X and Y here. Because this A and this B are not this A and B. These are just placeholders. So what this is saying is I take the first whatever the first number or letter is, and I multiply it by 2, and I take the second letter and multiply it by 3, and then I add those. Okay. So to check for associativity, I have to check A star B star some other number or variable C, and I have to say, is that equivalent to A star B star C? And again, these A's and B's are not these. It might have been better with X and Y here, but this A does not equal this A. This is just a placeholder, meaning whatever's here, I replace here. Whatever's here, I replace here. So let's try this out. So we're going to work within the parentheses first. Okay. And so this becomes A star B. Forget about this star for a second. A star B is just 2A plus 3B. Okay. And then I still have star C. Okay. So now this is my new A. 2A plus 3B is my new A right here. So I replace this A with this, and this becomes 2 times 2A plus 3B. Star, the second one, which is now a C, I replace it here. That becomes, actually plus, sorry, this plus right here. Plus, I replace the C, since it's the second one after the star. I replace this B with this C, so this becomes 3C. And then I simplify it as much as I can. So this becomes, I should have equal signs here, equals 4A plus 6B plus 3C. And then I do the same thing here. So A star, B star, C. So first, I'm going to do B star C. So this equals A star, and don't get confused here. First one star, second one. The first one gets multiplied by 2, so this becomes 2B, plus the second one gets multiplied by 3, so this becomes 3C. And then we start over again, and we have the first one, A, and the second one is this entire thing. What happens to the first one? Well, it's multiplied by 2. So this becomes 2A plus 3 times whatever the second one is. So I'm going to replace B with all of this. So that becomes 3 times 2B plus, oops, I forgot the B, 2B plus 3C. and this equals 2a plus 6b plus 9c. This is not equal to this. So we can say that this, which is not equal, I guess we could say it, this is not equal to a star b star c all the way down. In other words, this is not equal to this. So we can say that this binary operation is not associative. It is not associative. Okay. And then let's just do letter B real quick. A star B is equal to A plus B plus AB. Or first star second equals first plus second plus A times second. So again, we got to check out is A star B star C. We got to work that out. Is it equivalent to A star B star C? Okay, so let's work this out. A star B, this is going to just be A plus B plus AB. Okay, star C. So this was our first and our second. Now this is our first and this is our second. Okay, so this turns into a whole big giant mess. The first one, anywhere I see an A, I replace it with this. And wherever I see a C, a B, I replace it with C. So A gets replaced with all of this. So this A becomes A plus B plus AB, this A right here, right? Plus, then this B becomes a C, plus, I'm gonna have to, let me do this, equals, and then plus this A, right? A, it's the first thing, becomes A plus B plus AB. And this B, A times B, becomes a C, right? And if we do some algebra just to save time, I am going to tell you that that is equal to A plus B plus AB plus C plus AC plus BC plus ABC. Okay, and now let's see what happens here. A star, B star C. Okay, and I'm going to draw a little line here. This equals, let's take care of the parentheses first. So we have A star, B star C. Okay, so B star C means wherever it's first and second. So here's my first. Wherever I see an A, I'm going to replace it with a B. So this becomes B plus, and wherever I see a B, I'm going to replace it with a C. So B plus C plus BC right there. Okay. So now I go back to here. My first term, this is nice. Wherever there is an A, I'm going to replace it with an A. Whenever there's a B, I have to replace it with this big giant mess. Okay. So this A is replaced with this A. This B is replaced with all of this. Plus this A is replaced with this A. And then I have to multiply it by all of this. B plus C plus BC. And that becomes A plus B plus C plus BA. I'm going to write that as AB. And the plus goes here. Plus AB plus AC plus ABC. And if you look, this is equivalent to this. It's not necessarily in the same order, but it is equivalent. So we can then say that star is indeed associative. All right, that's it. Hope you enjoyed it. I know I did. We're going to wrap this up, seeing how Ellie is doing. Is she still burning? I bet she is. And I am